Welcome. Today we're going to talk about relays and how to test them, how they work. So the plan is we're going to go through, we'll give you a little presentation on their background, understanding the terminals and so on, and then we'll be moving over to doing a lab presentation. So let's start talking about it. Relays are used throughout the car in many different locations. I'm going to focus today on the 4-terminal relay, commonly the Bosch relay. I'll use that numbering system. There is other numbering systems that are out there, but once you understand the logic behind it, it doesn't matter. You can plug in your numbers accordingly. As you can see here, they come in all different looks and configurations, and they all do one thing. They simply take a low current input and they're going to make it into a high current output. So you're going to simply switch. It's the same as the old-fashioned switches that one would have. We turn it on and off, but it's hard to have them to hold enough current because you have that arc. So we end up going with a relay that can do work, and if we need to do a lot of work, we're going to move to a solenoid. So there's a lot to it, and we're going to be talking about pin 30, 85, 86, and 87. So that's a terminology that we need to be very aware of. So that's a standard that Bosch Corporation put forth with relays. It's kind of universally used, but I said you may run into the relay you have may simply have 1, 2, 3, and 4 on it. So the identification of each one of them is going to be critical. So when you're going and doing the on-car repair, you're looking at the right terminal and what it does. So we have here, in very simple form, our terminal 30 is going to be our main power input. That is actually what's going to be carrying the high current that's going to be made available to the component we want to run. And today we're going to talk about simply a simple starting circuit, and I will explain a little later what my props are going to be identified as. But the simple circuit with the example here is we want to run a starter motor. Could be a blower motor, could be a fuel pump. They're all going to work the same way. The next terminal we're going to be concerned with is terminal 87. And that is going to connect to the item that's going to be energized. In other words, that has to do the work. So again, could be the starter motor, could be a blower motor, could be your fuel pump, or anything, your headlights, so on and so forth. And then we're going to have terminal 85 and 86. That's really your switch. What that's going to simply be doing is going to be taking a low current input and either going to be bringing a low current plus voltage or supplying a ground, depending on how it's configured. But either one is going to be the way it's going to, we need to be aware that it can be wired both ways, but 85 and 86 are where that's at. If you can see here in the diagram, we are simply bringing in pin 30 is going to have the high current. High current is going out. When that switch is closed, that allows the high current to flow. But we're going to have a coil, a wire, that's going to be energized, and it's going to bring in a power and supply a ground. That combination isn't real critical and not always very uniform. So be aware that that uniformity may vary from wiring schematic to wiring schematic. But the orientation is critical, but it is commonly violated, so be aware. Okay, as we break down the components here, we see that we have a coil around a solid piece of iron, and it's simply going to produce a magnetic field. So the magnetism that's going to be produced will simply pull the little arm down, and it will take our power that's coming in. So our power is coming in here on this terminal. So pin 30, making it available at that contact. That's usually a fixed contact. And then we're going to have pin 85 and 86. So let's look how they're wired here. So in this particular case, we're coming in and we have 86 is going to be coming in here, and that's going to be switched. So your computer, a switch on a dash, something is going to supply switched, in often cases 12 volts, but it can be different. 12 volts to this, energize the coil, and supply a ground. When we do the demonstration, you can see I actually will run it the opposite way. We'll actually be looking at some stuff on ground side control. Then ultimately is pin 87. Pin 87 is when this contact's close, and we're going to supply that high current now to the load, whatever that load's going to be. In today's demonstration, it's going to be to a solenoid, a starter solenoid. Actually, a small starter solenoid with a given problem. We'll see if it shows up when we do the demo portion. Okay, here's to identify what we have. So in the fuse box itself, I need to determine, so we're going to look at the starting system. So you can see in our diagram here, we need to identify what's going on within the fuse or relay center itself. So within the relay center, we need to determine what we're looking at here. So for the crank, so we're talking about crank, so it's going to be number 2 fuse. So number 2 fuse, what do we got here? So we got number 2 fuse. And then we're going to crank it over with this relay, so that's number 11. So number 11 relay is the series here, so we'll put it kind of in perspective. And number 11 is this relay here. So we've identified the 2 things that we need to know. Where is the current that will be outputting to the solenoid, in this case, and where's actually the relay itself. Then we want to have a wiring schematic. So the wiring schematic is critical to have an idea where things are going on the fuse box. There is some universal rules, we'll cover some of them, but mainly you need to determine off a wiring schematic what is taking place here. Now this particular design is going to be a ground side control. So the pin here, pin number 85 coming in is going to be hot, and then in our case here the yellow wire is going to be ground control, so that's going to be switched on the ground side. So that particular system, and then of course it's pretty self-evident that we have our relay, we got our power coming in, and what it's going to do is simply going to come down to our starter solenoid. So between these two, so the control side and the controlled side. So wiring schematic is absolutely imperative to for any kind of troubleshooting. But there is a couple workarounds, but we always default, I would say 99.1, it's got to have a wiring schematic. Okay, the next item we're going to talk about is electromechanical solenoid. The difference ultimately is that the solenoid is able to take very high current, where relays are going to be limited. And it just might be a little bit more of a nomenclature as far as how you identify the component itself. So in this case here, we have really the same components. We're going to simply have an ignition signal coming in. This is a grounded style solenoid. I'm going to be demonstrating with it ungrounded, so it's going to have to be supplied to ground. So there is differences out there. So this would be a ground side we're illustrating here, and we're going to supply power in, finds a ground, energizes the coil. there's a rotator in this, and it slams down, and it just makes this connection. So your battery terminal coming from your battery source now has power through this disc over to the other side, and in this case to the starter motor. So very, very simple process. Now let's talk about things that go wrong with relays themselves. With relays themselves, there could be a lot of this. So I just grabbed a little 5 terminal here, a little micro relay, and they can get submerged. Since I'm around fresh water and don't have salt water to have the car submerged or vehicle submerged in, we see a lot of slow, gradual deterioration of the wiring. But it occurs with fresh water, just not at the rate that it occurs with salt water. But to our coastal friends, we have our own road salt. So we import our corrosion, not to be confused with the vehicle being dipped in it with hurricanes and the like. But as you can see in this picture, we got a lot of corrosions. Corrosion's a very common problem, and it will be the reason more often than not that you're doing the electrical work. If it is an impact or, from the vehicle being damaged or in some other kind of service, the wiring being damaged, typically I have seen that most of the problems we have are going to be corrosion related. So always think about that in the background. Odds are there's a problem corrosion related if the vehicle's had any kind of service life. Now the relay itself, that's where it's hidden. It's hidden under that little cover. Now I have this one removed, so this is a good relay, but normally we're just get the cover there. We can't see this. So we don't know if the problem is corrosion inside that relay or not. In a relay box like that, not real common to see corrosion unless the vehicle's taken a dip. So if the vehicle's taken a dip, the corrosion can be everywhere. Normally, these are a lot of the relays that are mounted in unusual locations and can have the situation where salt water can blow in there. But as an example, this has a cover on it. The cover was left off, and we had salt mist coming in from road salt. Can very easily deteriorate if the seal on the relay is not good. And they do get cracked. I've run into before. I've seen them cracked, so that can compromise the relay itself. So be aware, this is one that I had actually found and did a repair on it. It was an intermittent problem. The component in this case here was the fuel pump. It was running very slow, not developing enough fuel pressure. It had the second pump in it, of course, and ultimately ended up being the relay itself. It was clicking, it just didn't, it was dropping all the voltage. So simple voltage drop check found it in that case there. And so no crank, that's what we would find in this case here. Fuel pump, and there's a lot of different things that you're going to run into. Lighting circuits, so on. So be aware of that. Okay, one of the things that I've seen and got to be aware of, most of the time your relay is going to be equipped with a means of dampening out the high voltage that comes back. So you're going to have this tendency to have, when the relay is closed, we simply consume all of the voltage. When the relay opens, so in this case it's a ground side control, when that relay opens, that energy that's built up in the coil is going to work just like an ignition coil, and it's going to fly back into the circuit. So depending on how it's wired and so on, you've got to be aware that that flyback voltage is very real, and it can damage things throughout the system, especially ECM, PCMs, radios, and the like. So where this really becomes a problem is a lot of times when aftermarket relays are installed, you end up with this problem of the relay being installed, and now you got things that reset or get damaged for some reason or another. And you got to make sure that you're taking care of that and making sure that there isn't a spike. In a future episode, we're going to talk about getting a little more sophisticated, looking for these exact kind of problems. Okay, we're going to start on our lab portion. What I have set up today is, this is a relay with a known intermittent problem. It was off a smaller UTV, so it was not a car, but works very similar other than the wiring configuration. We're going to use the headlight as the load. In this case here, the headlight is going to represent the load in the circuit. So we'll say, for example, this is going to be our starter motor. So you'll have a visual illustration of what's going on. So what I have set up here is I simply have, this is going to be, this little switch is going to be take the place in this particular application of the ECM. The engine control module is going to control the starting. So the module would go ahead and in this case here, it's going to find it a ground. If you look carefully, you'll see this is the black wire is representing the ground. So I'm going to the ground on my power supply. And that's coming in, and then I'm going to have two sources of power. So this is going to be our main power coming in for the fuses here, and then I got this other orange wire that's coming in, and that is on the other side of the relay. So we'll go ahead and we'll depress it, and you can see here we've got the relay that clicks, and I am in this case here supplying 12 volts from the contact. So I'm just simply depressing this here so you can see it mechanically occurring, and that is energizing that coil, supplying a path across here, and in turn putting power to our starter. We're imagining this is a starter. So let's go ahead and do some electrical tests. This is a simple way of doing it. Some people actually take the tops off and make themselves a little test relay. Nothing wrong with that concept. So the first thing I'm going to do is I want to make sure my system voltage is good. So I normally like to run a meter. Since we have a lot of variances, I'm going to go over to the range select, and I'm going to set it so we're going to be at 12 volts. I'm going to have the decimal point right in the center. So I'm going to be going down to, in this case here, single tenths. So we'll be looking at no more than 12 volts, so that would be fine here. So let's go ahead and hook this up. And we can see on our particular application here we have 13.89 volts. So that's the first thing you always want to do. No matter what, check the battery. I have seen too much diagnosis over my many, many years of doing this that people don't check the battery, and then you are trying to literally chase your tail. So that is critical. So I'm going to leave the ground hooked up here, and I'm going to move this over, and we're going to go ahead and we'll go ahead and verify. In this case here, I have two probes coming off, and this is going to simply be so I'm going over, and I have a wire that's going over, and that's on the 12 volt side. So I have 12 volts coming in, and then I need to, so I expect to see that voltage there. There's no load in the circuit. Now I'll hook up here, and I wouldn't expect to see anything on. We're on the other side of the relay going to the load. Well, once we apply it, now I suppose everybody's asking, where did our voltage go? Well, we're going to have voltage drop throughout the wire in itself because we've put a load on it. So the static voltage is in the battery. Even if we were on duplicating with the charger or something like that, it's going to keep the battery 100% stable like this is. We are still going to have a certain amount of voltage drop. We can go back on the other side and see if it's coming on our supply or across the relay itself. So in this case, it looks like it's our wiring itself. Now this relay we'll see, will intermittently not light the light because there's a bad spot on the contactor. That's why it was changed out. So maybe we'll see it. maybe we won't. It's really intermittent. Okay, the next item I'm going to do is I'm going to pull out the relay itself. So we'll go ahead, turn our power off. And I want to demonstrate here what we have. So I labeled it for clarity. I'm just going to take a back probe adapter, one of Snap-on's back probe adapters, and I'm going to go into pin 30. So remember, that's coming in through this circuit here. That would be your main power, and if this was on a car, that would be going directly over to the battery. So this pin itself is tied right to the battery through a fusible link. And then I have on the other side here, I got pin 86. So in this case, pin 86 is going to represent 12 volts. So it'll be our 12 volt system. And over on the other side here, so these relays, how they do is just think diagonal. So 85 and 86 we talked about are going to be common, and then pin 30 and 87, that's our high current. So that's the combination. So it's kind of a simple way of thinking about it. It's that diagonal. And so I verified, and one of the things a person could do is if you wanted to verify on the crisscross here, let's go over here, and we know that's 86. And I told you earlier that I have the power coming in, so it'd be the same as removing the fuse. The power is gone. So that would be a very easy way of determining where we're at. Now we got to look at the others. So we're going to look at where we're coming in here. Pin 30 is going to come over to 87 and supply current to the, in this case, to the solenoid. So let's go ahead and get ourselves set up to do that. For this case, I'm going to simply use some jumper wire assemblies go right to the meter. So I'm going to grab 2 of these, and I got to prep my meter at this point. And the goal is not to blow any fuses. So we're going to unhook from the volts. We're going to go over to the amps. I'm going to set the meter on DC amps. I'm going to make my hookup. And in this particular case, I want to make sure I don't want to go across and put in a dead short. Well, this is the part that's very, very, very critical. Since I've identified the pins, because if you go across this, I'm going to put 10 amps, and if I turn it on, and this was the engine control module, and it tried to send a signal out, it could easily damage. You could easily damage a transistor. So this part here is getting a little bit more dangerous. So I'm going to go in here. We said 30 is going to supply us power. And now we see how much current it takes to operate that solenoid to the motor. So remember, we are simply running the current through the windings of that solenoid itself. Let's go back a slide here and talk about solenoids. So within a solenoid, I am simply, we're going to find our laser pointer. What I'm simply doing is I'm looking at the coil of wire, how much current is going across it. So that's the objective here, is how much current is going to be applied at that junction. So just so we go start from the top again. Now on the other side, we have a couple different options. I can take a test light, and we do something very, very similar. One thing I want to remind everybody, simply whenever you're done with your multimeter, your DVOM, when it's in amps, always 100% of the time, unhook it, put it over here, back to voltage, and turn it off. That is going to be the best practice and to save you fuses and looking stupid, because if you go, next thing you're going to do is check a battery, this 10 amp fuse is going to smoke. And when that 10 amp fuse smokes, you now have a fuse that's gone, and next time you do current measurement, you're not aware that the fuse blew, and sometimes you're just measuring the ether. So rule is always to make sure you do the switch back. Okay, so I have a test light here, and a test light simply set up to ground with this little plug, so it's a little different than probably the one in your toolbox. It's set up for this. And I'm going to see, and we're going to go to power. So I'm going to go ahead, and in this case, I will simply use a back probe. Go over here. There's power. There's power. We're exactly where I was expecting it to be. Now, I want to do is I want to check pin 85. I want to see what's going on there. So I'm going to go over here, and I'm going to take what would be the ground for our test light, and I'm going to move it over to the plus side of the battery. Now that's on plus side of the battery, when I go over here, I don't see anything. I go here. Now, of course, I don't see anything, but now we're going to attempt to crank the vehicle. As we crank the vehicle, what happens at that point is we are supplying a ground for this. Okay, as we come over here, pin 86, we supply a ground, and the light illuminates. So quite a few different ways of approaching electrical problems with relays. So you can take them apart. They make a variety of relay testers. They also, you can use the voltmeter, you can use the test light, but key there is to determine exactly what each pin does. And I know that's the biggest mystery out there of determining what the pins are. So at least now you can identify what the business end is. So if I want to simply make this item operate, whatever it might be, I would simply do like I did with an amp meter. I would go between pin 30 and 87, and it will energize the component and will validate that it works. So if you don't take away anything else, that would be one of the keys here, is to make sure that you have that basic test down. So I want to thank you very much for listening and observing, and make sure you subscribe, and make sure I get a thumbs up, and have a great day.